Okay, my advanced geometry classes have a test coming up on Friday over some triangle information. So we have the triangle inequality theorem, we have the triangle angle sum theorem, we have the exterior angle theorem, and the midsegment theorem. Okay, so those are all the things we're going to talk about with triangles, as well as isosceles and equilaterals, right? And what happens with the algebra with isosceles and equilateral triangles. In addition to all of the stuff we've already learned about triangles, like angles, like vertical angles and supplementary linear pairs and parallel lines cut by transversals and all that other wonderful stuff. So looking at number one, hopefully we recognize there is a relationship between these two angles. Okay, what are these two angles called? These two are called vertical angles. And hopefully you remember that vertical angles are congruent. So if this angle is 35 degrees, then its vertical friend over here is also 35 degrees, making x 35. And since this one up here also says x, it is also 35 degrees. So we know two of those. So now we have this figure, right? This is called a triangle. Hopefully you all know this is called a triangle. And y plus 35 plus 35 has to add up to 180, right? These three angles, 35 plus 35 plus y, needs to equal 180. These are the three angles of a triangle. So y is going to be 110, because that's what 180 minus 70 is when we combine our like terms. So y is 110. Now there's two ways to do z. Z is an exterior angle. I hope we recognize that z is an exterior angle. And exterior angles are equal to the sum of these two, right? The two remote interior angles, right? So that's one way to do it. And the other way is to say z plus y equals 180. So either way, whichever way you choose to do, this comes out to be 70, right? 35 plus 35 is 70. I know yellow is not very visible, so let me change it to this color. 70 is the value for z. Okay, so there's a lot of things that we've talked about with angles in this single problem. Vertical angles, we have congruent angles, and oh, by the way, what kind of a triangle would this be with two congruent angles? It would be isosceles, and it would also be obtuse, because it has an angle greater than 90. So this is an obtuse isosceles triangle. Okay, because it has two congruent angles, which means that these sides opposite them have to also be congruent. So lots of information about triangles on this one problem. Okay, number two. Find x and the angles. So hopefully once again you recognize this as being an exterior angle, right? 120 is exterior. So there's a couple ways we can solve this. We can say that 120 equals 3x plus 2x plus 15, right? Angle G and angle D are your two remote interior angles. Or if you don't see that, then this one needs to be 60, because those two make a linear pair. So they have to add up to 180. So we could also say that 3x plus 2x plus 15 plus 60 equals 180. Okay, so both of those equations are true equations from our triangle and exterior angle situation here. Okay, so we need to solve either one of them. We solve for x, so I think this one might be easier to do. And I get x is 21 when I subtract 15 from both sides and then divide by 5. So the x value is 21. And now it asks us for some angles. So remember, when we're given three letters, the letter in the middle represents the angle we're talking about. So DFG is this angle right here from D to F to G. And we notice that is a 60-degree angle. So now we put a degree on our answer, because it is a degree. Okay, and now FDG. So FDG is this one up here, F to D to G. And if X is 21, we plug 21 in here. 2 times 21 is 42. 42 plus 15 is 57 degrees. And then the last one, 3 times 21. 3 times 21 is 63 degrees. So we have 60, 57, and 63 degrees. Okay, two sides of a triangle are given. Find the range of values for the third side. Okay, so this is a triangle inequality theorem where the sum of any two sides of a triangle have to be greater than the third side. Okay, so there is a smallest possible value that we could have and still have a triangle, and then the range up to the largest possible value. Okay, and if you remember from earlier in class, we find the smallest possible value by subtracting 32 minus 20. So 12 will be the smallest. Now 12, of course, it can't be equal to 12, so we use the inequality symbol, right? Strictly greater than. Our third side has to be strictly greater than 12. Okay, and I'm representing X as the value for the third side since it can change, right? It's variable, so we throw in the variable X. So it has to be greater than 12, so 12.1 or 12.09 or something like that. And to find the largest possible value, we add the two things together. So 32 plus 20 is 52. Now it cannot equal 52, or you're going to have two segments of equal length. So 51.9, 51.95, right? So we use the less than symbol. X is sandwiched between a lower bound of 12 and an upper bound of 52. Okay, so that's the range of values. Anywhere between 12 and 52 is good. So same thing for number 4. We subtract the 2 and we get 6. We add the 2 and we get 26. So we have a range of values from greater than 6 to less than 26 feet for the third side of your triangle. Okay, number 5 is again a triangle inequality theorem where the largest side is across from the largest value. So greatest to least, this is a 90-degree angle, which means the top one is a 60-degree angle. So the greatest side length is going to be side B, and then the next greatest side length is going to be C, the middle, and then the smallest side, side A, right? These are all lowercase letters. So side B, side C, and then side A that are across from the largest angles. Now here we have angle measures, and these should be capitalized, so I'm going to capitalize them because that's usually how we see them. So let me erase this poor notation. So 6.5 is across from angle B. 4 is across from angle A. And 3 is across from angle C. Okay, the largest side is across from the largest angle, and the largest angle is across from the largest side. Okay, in this one we are given the measures of 3 angles, and we want to know the shortest side. So if we're going to find the shortest side, we need to identify the smallest angle. Okay, and in order to do that, we need to know the value of X. So if we have 3 angles for our triangle, what do we notice about their sum? Excellent answer. We know that the 3 angles of our triangle add up to 180, right? We know these are all angles. Angles add up to 180. Nothing else adds up to 180 except for angles. Okay, combining like terms, I have 2x plus 5x plus 2x. That's 9x. I have 8 minus 4, which is positive 4. 4 plus 32 is plus 36 equals 180. Okay, and now we're going to subtract 36 from both sides. 9x equals 144 when you subtract 180 minus 36. And then dividing by 9, what's 144 divided by 9, calculator? 16. So x is 16. Excellent. So now we can figure out which angle is our smallest. So angle A, 2 times 16 is 32. 32 plus 8 is 40 degrees. 5 times 16 is 80. 80 minus 4 is 76 degrees. 2 times 16 is 32. 32 plus 32 is 64 degrees. So angle A is the smallest angle, right? Angle A is only 40 degrees. And the side across from angle A is going to be side BC. So BC is the shortest side of our triangle because angle A is the smallest angle of your triangle. Okay, number 8. This is a wonderful picture here. Let's put in our information. CAB, angle CAB, that's right here, 10x plus 2. And angle CBD, that's this outside angle here, 25x minus 31. And we want to know what is the measure of angle BDC. So this angle right here is what we're trying to calculate. All right, so what do we notice about this thing? Hopefully you notice that this is a special type of triangle. That's an isosceles triangle. In addition, right, there's another tick mark here. So BD is also an isosceles triangle. Okay, that's helpful. That's helpful. So I know that these two angles of my isosceles triangle are equal, right, for this triangle here, ABC. And I also know that these two angles are equal also, right, because they are base angles of a separate isosceles triangle. So if I could figure out what the value of x is, I can get what that angle is, right? And then I can do 180 minus that angle and divide it by 2, and that would give me the measure of this guy. So if I can only solve for x, what else do I know? Well, I know, right, ABC, that if this is 10x plus 2, this angle right here, then the top angle is 10x plus 2. And how can that help me? They're all equal to 180. If I were to know what this angle is, then I could say that they are all equal to 180. Those three angles, since 25x minus 31 is not involved in triangle ABC. But what if I, for a second, ignored this line right here? Just for a second. If I ignored it, then what kind of an angle is 25x minus 31? This becomes an exterior angle to triangle ABC. Okay, so 25x minus 31 is an exterior angle. And these are the remote interior angles. So when I see that, when I understand that 25x minus 31 is a exterior angle, that has to equal 10x plus 2 plus 10x plus 2, right, which is double. I'm going to double the 10x plus 2, adding them together. I guess we can add them together. Maybe that would be more appropriate since that's what we've done this whole time. Plus 10x plus 2. Okay, so this is my exterior angle, and these are my remote interiors. So this is a true mathematical or geometrical relationship. So let's see, 20x plus 4. I'm going to subtract the 20 to this side, and sorry, I'm going to move over here. And I have 5x. I'm going to add the 31. Adding 31 to 4 is 35, so x equals 7. X equals 7. Well, that's good. I needed to solve for x. X equals 7. So now I can find the measure of my orange outside angle here. 25 times 7. 25 times 7 is 175. Minus 31 is 144. So this angle right here, this orange angle, is 144 degrees. So 180 minus 144, that's 36. 36 divided by 2. Both of these angles are 18 degrees. Okay, there was a lot of work involved in that. And it first comes by recognizing that this is an exterior angle. Okay, it's an exterior angle for an isosceles triangle. Okay, speaking of isosceles triangle, triangle ABC is an isosceles and the vertex angle is B. So let's draw this isosceles triangle. That doesn't look very isosceles, does it? Let's try again. There, that's better. Here's your vertex angle. This is called angle B, which means your base angles are A and C. And those are your congruent ones. So there's your isosceles triangle. We are told that angle B is 12 less than twice angle A. 12 less than. Okay, so angle B is 12 less than 2 times angle A. So we have to have angle A before we have less than 12, right? Less than works backwards. We have to have a value first and then less than 12. 12 less than. So angle A, I'm going to call that my variable. How about we do that? So that means angle C is also x. And angle B is 2x minus 12, right? So I am creating equations. I'm creating expressions for my 3 angles. And then I can say my 3 angles add up to 180. My 3 angles add up to 180. And then I can get 4x equals 192 when I add 12 to both sides. Right, so this is a minus, so I'm adding 12. 192 divided by 4 is 48. So both of my angles A and C are 48 degrees. Right, they're both x. 2 times 48 is 96. 96 minus 12 is 84 degrees. So this would be an acute equilateral or acute isosceles triangle because all the angles are less than 90. Okay, and our last one says, given these measurements, is this an isosceles triangle? So if we subtract the 2 angles that we know from 180, 180 minus 60 minus 55, I get a 65 degree angle. And since none of them are congruent, we would say no, this is not an isosceles triangle. It is a scalene triangle because scalene triangles have no congruent sides. Okay, and that is the first page of the triangle review. So if you want to do the second page, watch the other video. Okay, goodbye.